Oh, that's not good.
Did you test your presentation?
Nope.
Credibility trap.
Where's my mouse? What? Alright, give me a sec. So I can't see my mouse, so I can't close this little bubble thing. Oh, this works. Alright, hey, I'm Nick, and I'm going to be giving a talk on software testing today. Now, if at any point during the presentation you have any questions, feel free to ask me. There'll also be a bit at the end if you have any longer questions or you can't think about questions till then. So, first up, what is software testing? So, software testing is the process where we verify software to ensure that it works as it needs to meet requirements, to meet customer needs, or to make sure that it's not erroring, or things like that. Now, software testing can be automated or manual. Kind of the processes that we need to use to know what to test can be similar between manual and automated testing. However, whenever it's possible, we are going to want to be using automated testing because when we have a test that we can just execute on a computer repeatedly, it's a lot more efficient to kind of share these tests between teams and save time on testing so that we can do it more frequently. However, in some more complex scenarios, we might actually have to rely on manual testing. One good example, maybe you're writing a three-dimensional video game, kind of doing graphical tests on that automated wouldn't really make sense. However, again, we can still use some of the ideas that we're going to have in this presentation and apply to manual testing. So, why should I test my code? You want to make sure that your code satisfies the requirements of your software. You also want to be able to catch bugs faster. So if I can run my tests, especially if they're automated, I can catch bugs faster, especially if I test before all of my development is done. We also want an unambiguous way of determining if code, whether it's an entire system or a user interface or just a unit of code, works after we make a modification to another part of the code base. This is known as regression testing, where you basically rerun a test that you already knew passed in the past after you make a change to make sure that that change didn't break some functionality that you already proved worked previously. We also want to add flexibility and efficiency to development of the project by sharing our tests with our team. Continuous integration is a great way to run your tests, whenever you push to GitHub or something, your continuous integration system can run your tests. Brian gave an awesome talk on that a couple weeks ago. I'll also have a link to his slides at the end if you want to take a look at it. All right, so now we're going to talk about some methods that we can use for testing. Now, a testing method defines the aspects of a code base or a software project that we're going to test and how we're going to test them. There are a lot of tools that are cater to specific testing methods, but a lot of the time you can use a test framework for multiple methods, so don't worry too much about tooling at this point. It's very common for software projects to use multiple methods of testing. Usually one is not enough, but it really depends on the project and depends on the requirements of the project. For example, if you have a project that's being developed for a government contractor, security is a big concern. So you may want to have more tests that ensure that your code doesn't have security vulnerabilities. However, for some personal projects, that may not be necessary. So it's important to think about what testing methods you need before you start testing your application. Again, depending on the language and framework you use, usually most of them have test frameworks that work with a bunch of different testing methods. So the first method we're going to talk about is unit testing. So unit testing lets us test an individual unit of code separately from other parts of our code base. Unit testing is a way of verifying that a piece of code works whether or not another piece of code is working. So it helps us kind of hone in on where our problems are happening when something fails. Unit tests are also considered to be white box tests. What that means is that a unit test relies on implementation details of the application and possibly even its runtime in order to be able to call methods and make sure that they return what they need to return, for example. So we're going to think about what we need to know when we're going to plan or write a unit test. So first off, obviously, we need to think about the unit of code that we're testing. Usually this is going to be a method or a function in my application source code base, but it could also be larger than that. We're also going to need to think about test cases that we're going to apply to the unit of code to ensure that it does what we need it to do. A test case is basically a set of inputs and outputs for specifying this. Now, when we think about inputs of what we need for a test case, which would, for example, be the kinds of integers we're passing into a method that we're testing, we want to think about equivalence classes, which are kind of classes of inputs based on how the code base should behave based on them. So for example, if I have a function that maybe doubles an integer, if I have a negative number, I know that if I double a negative number, I'm going to get a positive number. If I have a positive number, I should also get a positive number. So that means that I could kind of group positive numbers into one equivalence class and group negative numbers into another equivalence class and have test cases for each of these equivalence classes. We also have boundary cases, which are kind of the usually minimum and maximum values of what an input can be. So maybe if an integer has a certain minimum and maximum value, we're going to want to test these minimum and maximum values to make sure that we don't have off by one errors depending on how large or small the integer is. We also want to know what outputs we would be expecting from the unit, which again would probably be a function. So generally we're going to care about what it returns and what errors it throws, if any. And of course, if it shouldn't return an error, we need to assert that as well. Here's some tips for unit testing. So you want to try to test with as many equivalence classes of inputs as possible. And generally, you only need to have one input per equivalence class. So for example, for that function that doubles an integer, if I'm testing -5, I probably don't need to test -6 because I already tested a negative number. That's kind of within the range of the minimum and maximum integers available, because I know that both of these numbers are negative, and when I double them, they're both going to give me a positive result. We also want to share some common setup between our unit tests. So for example, it may be common for us to have have one implementation class that needs to keep creating objects from another class at runtime when we're running our tests. So we don't want to copy paste this code between every single unit test we have for this class. We want to kind of compose this to make our tests more efficient and easier to maintain. So we're going to look at an example of how we can unit test a very simple function. We're going to be using Ruby for this. And this method basically just returns true if the given string is a palindrome. So if you aren't familiar with Ruby, basically this automatically returns whether the word, which is the parameter for this function, is equal to its reverse. So reverse is a method that's on strings and arrays and stuff like that. But it's important to note that reverse is not on all types of Ruby. So we're going to want to think about test cases. So initially, we're going to want to think about what kinds of word strings do we want to be testing to ensure that the palindrome function actually works as expected. So does anyone have any ideas for test cases we can use for this?
Race car. Race car.
Yeah, so race car is a common palindrome. So we definitely want to test if something is a palindrome. Any other examples? Think about equivalence classes and boundaries.
Empty word, or basically the lack of a word?
Yeah, definitely. So we're going to want to be able to test that this still works if we have an empty string, because that's technically a palindrome since it's its own reverse.
Maybe multi-word palindromes, like rats live on no evil star.
So basically just making sure that if we have spaces, it still works.
Yeah, punctuation.
Interesting.
Like that.
Yeah.
$, $, $.
You're brutal. Alright. So I think we covered most of these, but these are the test cases we're going to want. So whenever our word is empty, it's a palindrome. Also, if a word's just one character, it's obviously a palindrome because it couldn't possibly not be a palindrome if it's just one letter. and if it has multiple characters, could go either way. If the word is null, we should probably return false because it's not a word if it's not a value. So we're going to start by just showing an example of actually implementing this. And we're going to start with a little Ruby testing library called MiniTest. So MiniTest is a kind of unit testing style library that comes with Ruby. So we're going to require MiniTest here. And MiniTest is an XUnit style framework. So what this means is that you're generally going to have one unit test class for every real implementation class that you have. And you're also going to have one unit test method for every real implementation method you have. So we're kind of mapping these to the actual code. So because we define the palindrome method, we're going to have a method to test it, test palindrome. And we have these assert method calls that assert that a certain return value is true or false. So basically, these are just the same test cases that we had on the previous slide encoded into MiniTest. And we also want to insert that if the palindrome is given nil, which is Ruby's null value, that it returns false. Now here are the results if you actually run this in MiniTest. So I wanted this test to have a failure just so that you could kind of see an example of what it looks like. And it turns out there's a problem with our implementation of this method. If you call reverse on nil, Ruby's going to complain that nil doesn't have that method defined. So if we go back to our code, what we should have done is check to see if it's null, and if it is null, we should return false. So our test is already doing something useful, so that's good. And at the bottom, we can kind of see navigation of how many assertions we've done, which are these assert true and false calls, and we have one error. And now we're also going to look at RSpec. So this is the same unit test written in a different test framework now called RSpec, which is kind of a BDD style framework. I'll touch on BDD a little bit later, but RSpec lets us kind of break down different contexts and conditions of a feature in a system and ensure that make more assertions to make sure that it's working properly. So in this case, we're actually going to separate out our assertions into different sections based on the equivalence classes of our inputs. So if an empty string, it should return true, and then we just have some more Englishy syntax, which is really similar to our assert true method before. It's just RSpec has its own syntax for this, and we have a context for every single assertion here. In RSpec, you usually have only one assertion in each of these if blocks, but you could do it either way. And then also, if we have a null value, this should return false. So you just pass false to the B method over there. So this is essentially the same test. You'll also have the same test result, but this thing's failing. I figured I'd not include the result since it looks very similar to the MiniTest ones. All right, so now we're going to talk about different kind of testing, integration testing. So this is another test message to be clear. And in integration tests, we have multiple software modules that are brought together and tested to make sure that they're communicating with each other properly. So I might have one module that needs to connect to a logging service in the back end, and I want to make sure that if I do something to this one module, logs the right things over to this other logging module. Now, I can use a testing tool called a spy to kind of wrap an interface and make sure that the methods that should be called are actually being called. So maybe I'll have a spy on my logger, and I'll make sure that the log method is called, I don't know, 5 times or something. And by the way, our test will fail if that doesn't happen. I'm not going to show you a code example, but a lot of test frameworks have features like this. Integration tests don't really need to know about the internals of the modules that they're connecting. However, they do need to know about internals of the system so that they can call methods on the modules and connect them together, since these modules might not actually have user interfaces. They might just be talking to each other behind the implementation. So this is technically a black box test, which we'll get to in a minute. Sorry, white box test. All right. We're also going to briefly cover acceptance testing, which is the process of testing a program to make sure that from the outside, we're meeting customer needs and we're meeting the requirements of our application. So acceptance tests are generally a lot more about what a user would see and what a user could assert themselves from what they're seeing in a system. Like generally, if you have a logging service that's internal to an application, you're not going to write an acceptance test for that because the user isn't really going to be looking at this. You want an acceptance test to prove that your application meets your needs. They also give us a way to prove, so acceptance tests are considered black box tests, the opposite of white box tests, because they simulate user actions from the outside and they don't need access to these internals. However, it's important to notice that we can still automate this. So there are a lot of testing tools that will let you acceptance tests, like web applications like Selenium can automate stuff in your web browser. And some of these tools require that you're using the same language for your actual application, and some of them don't. Another kind of testing that you don't want to use too often but can be useful in a pinch is smoke testing, which is basically performing a quick check to make sure that your application works at all, or just to make sure that it launches, because if we can run the smoke test before anything else, we have a very quick result on, like, is my application compiling or something like that. And we know that if our smoke tests are failing, something is very wrong and we probably shouldn't continue testing, we should immediately fix the problem. It's generally not enough to test your whole application since it's very simple and doesn't really cover any of the internals that like a unit test would, for example, but it can be useful if you have time constraints at the beginning of the project. So some examples of things that you want to smoke test are any compiling issues with your project, which would obviously mean that you can't really run your tests. You want to make sure that the application launches, or maybe if you're implementing an API, you want to make sure that if you call something that it just returns a 200, not really assert what it does, but just make sure that your API is up. Now again, smoke testing is not something you'd want to use on its own, but it can sometimes be useful with other testing methods, especially if your other testing methods take a lot longer to run, which can be the case. We're also going to talk about a kind of tool that we can use with our tests. This isn't a testing method, so we can use it with any of the testing methods we just talked about, but a mock object is basically just a fake object that replaces the implementation of a real object in our code to make it easier to test something. So for example, let's say that we have an application that relies on a really slow API, and this is a problem because our test suite takes hours because we're making so many calls to it. With a mock object, I could kind of replace my HTTP calls to this API and say, whenever you make a call here, just return 200 with this little list right here. Mock objects can make our tests a lot more flexible, but they can also make it more complex to set up our tests. So a lot of the times you don't always want to use mock objects, but it's important to think about how complicated it would be to set up, especially when mock objects need to mock each other. And yeah, one example of this is if I have a weather application that relies on an API. So, I'm going to talk a little bit about kind of software engineering practice dealing with tests. So depending on the process model that your project is using, or maybe you're doing a personal project so it doesn't really have that much of a defined process model, you may be deciding to perform your test before, after, or even during your development cycle. So kind of the waterfall way of doing this is to design your code, implement it, and then test it. So you'd be testing pretty much after you do all of your development. With more agile practices, we're going to start seeing that people are testing during sprints, during phases of development, and sometimes we're even writing tests before we write our implementation, which we're going to talk about in a second, test-driven development. And one of the problems with the whole waterfall methodology of only testing after your entire software project implementation is done is that you have all of these bits and pieces of code that are being brought together before they have any tests at all. And you're going to waste a lot of time trying to solve bugs, and you don't know if one module has a bug because it's being integrated with another module or because there's a problem with that module itself. If we had a unit test for that module, that'd be really useful because we could verify if the module works on its own, separately from anything else in the system. We're going to talk about one process, which is test-driven development, where we start writing our tests before we actually write the implementation of those tests. So basically, first off, you're going to plan what code you're going to implement. You're not going to actually write your code yet, but you need to think about what you're going to implement so that you can think about what you're going to test. And then when you know what you're going to test, you're going to start writing some basic tests, which are generally going to be unit or acceptance tests, but it depends on what your testing plan is. So for example, maybe if I was doing test-driven development with that palindrome function, I would just write my MiniTest test before doing the implementation and think about, well, obviously I need to know the name of the method so that I can write it out while I'm writing that. So it's not always going to pass immediately. Sometimes you might forget some implementation details that you need to change in your tests, but also changing your tests as you implement your code is a part of the test-driven development practice. Then we're going to run the tests. Now, this might sound silly because at this point we don't have any code implemented. However, it's important to make sure that all of our tests are failing right now, because if we don't have an implementation and one of our assertions about the implementation passes, something's really wrong. That probably means that that test isn't very useful because it's not actually asserting that something's happening. Then we're going to start writing the implementation of the actual code. And as we go through that, we're going to keep running the tests and we're going to keep writing the implementations and only moving on when the tests for the parts of the implementation we're writing are passing. And then you basically just stop whenever your test suite is fully passing. Behavioral-driven development, so it's very similar to test-driven development, but it kind of evolves it with more software process and more abstraction to be more like, I guess, business friendly. And generally we're going to see that people are talking in terms of user stories that we're implementing, if you're familiar with Agile, and making sure that our tests are asserting these user stories are implemented as expected. There are a lot of behavioral-driven development test frameworks. One example of this is RSpec, which we just used. So RSpec is focused on having kind of hierarchical specifications, just like we had our context separating out our equivalence classes within our palindrome test. We also have other styles of BDD testing tools, like Cucumber, where you have a file that represents a user story and doesn't actually have any test code, but you would then implement test code that connects to this kind of English definition of your user story. This is another kind of very popular family of behavioral-driven development testing tools. And these tools, as their namesake is, are really great for not only doing test-driven development, but thinking about writing user story specifications before you write your code. And for example, test frameworks like RSpec and Cucumber are going to allow you to mark methods as pending implementation so that you don't get as many noisy failures when you first run your test without any implementation. And it'll kind of guide you through what parts you need to implement based on what parts of your tests are still failing. All right, so I'm going to just go over some additional resources. This is basically the end of the talk, but if you want some documentation on how you can use RSpec more, go to rspec.info. There's also documentation for MiniTest at github.com/seattlerb/MiniTest. Those are just API documentation for these two frameworks. Again, MiniTest comes with Ruby, RSpec doesn't, but it's fairly simple to install, and they tell you how to do it as well. Columbus is a site and kind of user group in Columbus, but they also have a lot of really nice programming problems that you can do online on GitHub without physically visiting. And they have a lot of activities for testing. And if you want to kind of have some experience with behavioral-driven development, they have some great activities where you'll be writing tests before you're actually writing the implementation of some sort of web application. You can go over to here, and they basically just have like a bunch of GitHub repos that you can clone, and then you write code to make tests pass, or depends on the activity. Also, Brian Besmanoff's CI and CD talk is over at this URL, and this kind of goes over tools that we can use to automatically run our tests as our development progresses. and a bit more than that, but it does have some useful kind of uses for testing. Oh, any questions?
So if you're doing like behavioral driven development or you're trying to write your tests before writing your code, where does integration testing fall in that for you? So like, for example, you can spec out a specific module, but would you like behavioral driven development, it might be better like describing in those kind of like plain English senses like how the components will interact, but how do you handle that from just a test driven development perspective? Like, do you write tests to integrate the modules before you like after you spec out how the modules work, or?
So you're basically just asking, like, how would I do integration tests first using TDD or VDD?
Yeah, without having any like knowledge of the components.
I mean, to be honest, I haven't really seen that before. Usually, VDD and TDD tests are going to focus on unit testing and acceptance testing, since you're going to realistically be implementing individual modules of code before you start connecting them. I guess you could write an integration test and then actually write code that would pull the modules together. So maybe I would unit test one module of code, create it, unit test one module, create it, and then have an integration test bringing those together, and then I would write some sort of controller code or whatever you're doing to bring these modules together into your application's UI. So that should work, but it can be kind of awkward because integration tests often have like really long methods where you're kind of tracking a data flow through a bunch of different modules. So it probably isn't as convenient as unit testing, but you should be able to do it. Any other questions? All right. Thank you for coming. If you want to have access to the slides, you can go to mccurdy.io/testing-talk to get these slides. Let me know if you need the URL later.